Good morning again. My name is Franz and welcome to today's session. So today we are going to talk about one of my favorite topics, which is organic chemistry. So in a nutshell, we're going to talk about, or rather we are going to see carbon bonding with several elements in the periodic table, one of them being hydrogen, the second one being oxygen, and then the third one I'll make it as a group and call it X, which represents the halogens. So of these halogens, we will be seeing the likes of chlorine, we will see bromine, we will see iodine, and lastly fluorine. So we will basically see the relationship between a carbon atom with 1, 2, 3, 4, 5, 6 of these elements. And there will be laws that are going to be used to make sure that everything is put into place. So as I've already stated, it is basically the relationship about, or rather between carbon and these elements that we see here. Mostly, we will see the relationship that is going to take place between carbon and hydrogens. Many hydrogens that are going to take place, or rather, they are the ones that are going to be the major, or rather, what we can say in simple words, star actors. So let's check something here. Carbon has a valence of 4 electrons, or rather has 4 valency, a valency of 4. So what does that mean? It means that, let me just start here, organic chemistry. So like I said, it is chemistry of carbon atom, according to what I've seen after studying it for some time. Carbon atom. And then carbon has a valency of, or rather valence of 4. Carbon has a valence, I'll just say 4, valency of 4. So what does that mean? In simple terms, I can say carbon can bond with 4 maximum elements, can make 4 bonds, or rather maximum of 4 bonds, maximum of 4 bonds, meaning it can bond with a maximum of 4 other elements, you see. So if you remember in grade 10 or 11 when we did a particular topic whereby we were doing something of this nature, so this is single bond, single bond, single bond, and single bond. What will basically happen here? I'm going to show you again, Hori. We have carbon can have single bond, double bond, and triple bond. Three types of bonds. 1. Single bond. 2. Double bond. 3. And then triple bond. I'm going to illustrate how do we see single bond, how do we see double bond, how do we see triple bonds. So firstly, let's start with how do we see a single bond. A single bond is something like this that I've stated here. It's basically when we have one line, let me just put carbon here, one line between carbon and a particular other element, or rather, yes, other element. Another single bond that we can see, if maybe I put hydrogens here, it will be on this particular, in this particular fashion. So it is a bond between, it is one bond. It's practical in a sense that it is only one between hydrogen and carbon. I'm going to explain where do we get these 1s and 2s, and then I'll take you back to grade 10, come with you to grade 11, and then how we got to understand organic chemistry in grade 12. So this is the single bond between carbon and carbon and carbon and hydrogen. So I'll just say single, and then let's do the double bonds. So this is an example of double bond between carbon and carbon. And then another double bond that can be seen between carbon and a different element with it, which is not carbon. It is something like this. There is a double bond between carbon and that oxygen. So in a nutshell, carbon can have single bond between carbon and single bond, double bond, sorry, between carbon and double bond between carbon and other elements like oxygen. And as you remember, when I started this video, I listed here the different elements that carbon is going to bond with, and also oxygen was one of them. Now let me show you the triple bond in which carbon is going to, the one that carbon is going to make. So this triple bond is going to be like this: 1, 2, 3. See, so there is 1, 2, 3 bonds between carbon and carbon. You see, so this is single bond, and then double bond, and then double bond, and then triple bond. Something that we need to remember. I started by saying carbon has a valence, or rather 4 valence electrons. That simply means can bond with 4 other elements. And also it means that this carbon can only make a maximum of 4 bonds, or rather 4 lines moving away from it. In this sense, if we can check this first carbon, it is line 1, 2, 3, 4. So meaning it accommodates as 4 valence electrons. Let's come to this carbon again. It's 1, 2, 3, and 4. So that simply means it is covered. We do not have to have 5 bonds for carbon because it will basically exceed the number of valence electrons it has. Let's come again to when it has double bonds. So when it has double bonds, we will have 1, 2, 3, 4 for this carbon. And then this other carbon, we also have 1, 2, 3, and 4 bonds, which signifies, or rather show us the 4 valence electrons that carbon has. Even here, we have 1, 2, 3, and 4 for this carbon, and then 1, 2, 3, and 4 for this particular carbon. That is basically the most important thing that you need to take into consideration when you come to this particular topic. Someone would say, maybe I'm going up and forth, back and forth. I just want to give you the basics first, such that when we get into the mix, you now know, things become clear on why was I explaining to you the difference of valence electrons and then the different bonds, how it bond and how you count the number of bonds, and what happens if maybe you happen to miscount. You will basically have to see that you either undercounted the number of carbons or rather overcounted, which is basically going to make your structures be inaccurate. Let's proceed. Yes, so there are plenty of definitions that we will be having to remember in this particular topic. So I'm going to make an analogy trying to explain some few things. Number one, we will be having something called homologous series. So homologous series, if I were to make an analogy of this particular thing in order for you to understand, it is something like this. Say that you are a Soto, or when you are a Soto, and then Soto becomes an umbrella, and then under Soto we have different, I'll call it not tribes, but different as a tree, it has different branches, or rather people of different dialects, or maybe dialects will do, for lack of better words, sorry. So we will have Basia, we will have Bahlakwana, we will have Bakhatla, we will have Bafokeng. Okay, and many other branches under the Sotho culture or tribe. So what does this mean? It means that for Basia, they have what you call totems. So Basia, you see them with a cat. You see, Bahlakwana, if I remember well, is a crocodile, I think. I may be wrong. A crocodile. C. Bafokeng is a rabbit. Bakhatla, I forgot the name of this, the English name of the totem of Bakhatla. But nonetheless, I want you to get something here. So this is the Basotho. Under Basotho, we have the different branches of Basotho, or rather, yes, different those particular things, and then each and every one has something that it is unique about. If you see a cat, you remember Basia. If you see a crocodile, you remember Bahlakwana. If you see a rabbit, you remember Bafokeng. So meaning there is something that can be seen to symbolize, meaning it leads to something. In order for you to see something, to remember something, you see this particular thing. For example, I'll make an example with what let me say a Bible, for example. So Bible will make you think of God, make you think of religion. Bible is not religion or God, but it is somewhat something that leads your mind to think about something or to remember something, So that is basically what I'm going to show you. So homologous series in this case is the Basotho. And then we will have 9 different types of homologous series. And each and every one of those types of homologous series has its own categories, sign that leads that when you see this particular thing, it reminds you of that particular homologous series. It's something like a sign, you see. So a cat, Basia. Crocodile, Bahlakwana. A rabbit, Bafokeng. Bakhatla, I forgot their totem. So let's get into serious business now. So I said we have 9 different types of homologous series. Let me call this one A. 1, 2, 3, 4, 5, 6, 7, 8, and 9. The first homologous series will be what we call alkane. The second one is alkene. Third one is alkyne. Fourth one is haloalkane or alkyl halides. Alkyl halide. And then the fifth one will be, we will have aldehyde. Then we will have here the 6th one, ketone. The 7th one will have ester. The 8th one will have alcohol, not the one that most people drink. We'll have alcohol, and then we will have the last one, carboxylic acid. Cool. Now that I've listed this, if you remember the analogy that I made, these are the Basotho, and these are the likes of Bahlakwana, Bafokeng, Bakhatla, Bakwena, the likes. You see? So alkane, like Basia, like Bafokeng, has its totem, meaning it has what we call the functional group. So instead of in traditional ways you call them totem, but here we call them functional group. A functional group will be that signifying factor, something that when you see this functional group, it tells you that you have to remember that this is an alkane. When you see this particular functional group, you have to remember this is an alkyne, the likes and the likes, until you reach to the ninth one, which is a what? A carboxylic acid. So let me take your mind to the different types of functional groups. We have the first one. I'm going to describe each and every functional group of each and every type of homologous series that we have here. Number one, alkane. Single bond between, let me do this, use different color. Between, I'm going to use C for carbon, but now, yeah, I'm going to use C to represent carbon, C atoms. So meaning, okay, let me add something. And surrounded by hydrogen only. Hydrogens only. So whenever you see a structure that has a single bonds only between carbon atoms. I showed you what is a single bond. You see why I said I wanted to start with the part that I have to show you how carbon is going to bond, the single bonds, the double bonds, and the triple bonds. This is where it makes our life easier. So when you see single bonds between carbon atoms, and then that carbon structure is only surrounded by hydrogens, that is an alkane. If it is only single bonds and hydrogens only, nothing else, that is an alkane. So the alkane functional group will be that single bond between carbon atoms and being surrounded by hydrogens only. I hope this particular thing makes sense. Now, the second one, alkene. Double bonds between, change of color, between C atoms and surrounded by hydrogens only. See, again, alkene, double bond between carbon atoms. So remember when I showed you the double bonds, but this time around it's only the double bond between carbon and carbon. Remember I drew something here which was a double bond between carbon and oxygen, but in this case it is a double bond between carbon and carbon atom. Whenever you see double bond between carbon and carbon surrounded by that hydrogens, then you know you are dealing with an alkene. There is a special case, however, I'm going to show you later on the stage, whereby there will be something else that is not hydrogen that is affected there. That is basically part of the structure, but it won't make much of a problem or rather a fuss when we have dealt with things that I want you to know. So we did number 2, we did number 1. Let's go to number 3. I'm going to erase this part. Cool. Number 2. Sorry, number 3. We have alkyne. Alk and then the ine, that you, how to pronounce the thing. You say alk and then you say ine. Alkyne. And then number 3, we have alkyne. This one, it is triple bond. bonds, change of color, between C atoms, and also surrounded by, I'm going to say H for hydrogen, H atoms only. Yes. So here, like the triple bond that I showed you, I drew it already on the very same spot where I written this thing. Triple bond between carbon and carbon atoms. It simply means that it is what? An alkyne. When you see a structure, you see triple bond, that simply means that we are dealing with what? Alkyne. Let me show you structures. I think maybe the space is gonna be sufficient. 1, 2. I'll call this part alkene, and then alkene, and then alkyne, such that we become able to be able to remember this stuff. Maybe I should use red for drawing. Alkane, we said is single bonds between carbon atoms, so we'll have single bond. And then I'll just have those hydrogens there. And then we have alkene, double bonds between carbon atoms. And then we have alkyne, triple bond between carbon atoms. There's something that I want you to see here. As we increase the bonds between carbon atoms, we decrease the number of hydrogens. Let's start here. We had 1, 2, 3, 4, 5, 6 hydrogens. Here, we had what single bond here between carbon atoms with 6 hydrogens. Now, we have double bond between carbon atoms, and then we are left with 4 hydrogens. And then here, we have 3 bonds between triple bond between carbon atoms, and then we have what? 2 hydrogens. You see? So this tells you something. I will tell you about what you call the general formula, or rather general formulae of all of these particular 9 different types of homologous series, and that will help you to be able to, actually it's going to minimize the work that you will be having to do when given a particular question and asked to do, or rather write what we call the molecular formula of a particular structure. So these are the first types of homologous series with their functional group and exemplar illustrative questions, structural formulae of the first 3. Let's proceed. Cool. The fourth one, we call it haloalkane. Haloalkane or alkyl halides. I would like us to focus on the first name, not the or part. The haloalkane. It comprises of 2 words, halo and alkane. Let's focus on the second part of the name, alkane. Where did we see it? As a first, whereby we have already unraveled it and saw that it has single bonds between carbon atoms. Even here, haloalkanes, single bonds between C atoms. Important feature. Now, something else is being added here. The halo. The halo speaks about the halogens. Remember at the beginning of this video, I told you that we will be having a relationship between carbon and different types of elements. And then I represented halogens with an X, and then I showed you, listed to you the different types of halogens we will be dealing with here, as a chlorine, iodine, fluorine, and bromine. So even this is where they come in. Halo for halogens, and alkane that is bonded, or rather that goes with a halogen. I think that makes sense now. So now let's check. On top of the single bonds between carbon atoms, we will be having hydrogens and halogens on our structure. So meaning our structure is going to comprise of single bonds between carbon atoms and hydrogens. What did I write here? Hydrons. Hydrogens and halogens. You see, so it will be single bonds between carbon atoms, and the outer part of the structure we will be having what we call hydrogens and halogens. Now let's have the structure now, or rather let's remind ourselves of the types of halogens that we have. We will have halogens, and then we have 1 fluorine, 2 bromine, 3 iodine, 4 fluorine. Now, something important that we need to remember. I'll remind you also later, but I just want to say it now, since it's time. Fluorine, when we come to this particular topic, we will be calling it chloro. Bromine will be bromo. Iodine, iodo. Fluorine, fluoro. If I were to explain where these things come from, we'll be having a long day. But this simply means because they are the ones that have negative charge in it, in simple words. So now, what we need to do now is to show you the structure that will include these halogens. So there's our structure. Maybe the halogens, I can write them in red so that they become visible. Okay. So symbols of them, such that you remember: Cl, Br, I, and F. When you see single bonds between carbon atoms, and then when you see single bond between carbon atoms, and this is where the kicker is, hydrogens and halogens only, you have landed into the land of haloalkane, and that's basically how you distinguish between the first three that I've spoken about: alkane, alkene, alkyne, and then the fourth one will be haloalkane. So how do you see the difference between the first one, single bond between carbon atoms, and then being surrounded by hydrogens only? Second one, a double bond between carbon atoms, having surrounded by hydrogens only. Third one, triple bond between carbon atoms and being surrounded also by hydrogens only. And then the fourth one, which is this one, haloalkane, single bond between carbon atoms, being surrounded by a combination of hydrogens and halogens. That's where it ends, and this is for the first four. Let's go to the fifth. The fifth, I'm going to do it together with the sixth. such that we can see the difference, because a number of people tend to make mistakes with those two. Okay. I'll write them here, one there. Aldehyde, ketone. Aldehyde and ketone, on face value, they have the same functional group, which is carbon. Remember, when I spoke about the double bond between that carbon can have, as here I wrote the double bond between carbon and carbon, and here I wrote the double bond between carbon and oxygen. So here we are introducing oxygen being bonded to carbon with a double bond. Now let's check something. With aldehyde, the functional group is bonded to the first carbon, meaning the C double bond O will be on the first carbon. It won't be anywhere else. It will be on the first carbon. We are focusing on that. So it has a C double bond O, meaning a carbon bonded with a double bond to oxygen. You see, that's where the important part is. The carbon bonded with the oxygen double bond. That's where you see, oh, this represents an aldehyde if it is only on the first carbon. And then here, the carbon bonded to the functional group is between two other carbons. The same carbon bond, like C double bond O, in this particular part, it is placed in between two other carbons. But here, it is on the first carbon. Let me show you the difference. Here's the structure. Now, here's the structure. Let's look at the difference. Here, I drew two structures just to make sure that you understand. Here's our functional group. For the blue one, I'm going to use red. Here's our functional group. It is on the first carbon. It is on the outer carbon, meaning that the thing that separates it is closed by a hydrogen in simple terms. So it is on carbon 1. As you can see, there are 3 carbons. So we will say this is carbon number 1. You see? And then if we come to a different structure, or maybe where we have put this one is on the right, this one is on the left, this also is going to be on the first carbon. So meaning the C double bond O is always on the first carbon. It is not being closed in by anything else but hydrogen and carbon. But this one here, it has to always be closed in by 2 carbons. As you can see, there's carbon number 1 and carbon number 2 here. So they have enclosed this functional group in between them. They have encircled it and make it to be between them. It's like the president who's having the bodyguards. So this one is a bodyguard from Beijing. This one is an outlier, is outside. So basically, this is the difference between these two ones. It is an aldehyde. And then how do you see an aldehyde? You check, oh, we have C double bond O. Cool. Where is it placed? On the first carbon, or is it between two other carbons? If it is on the first carbon, it is an aldehyde. If it is on the second, or rather in between two carbons, then it becomes what you call a ketone. I think this for these two, you will never ever make any mistake. Let's proceed. We have done 6 now. We are left with 3. We have ester. Here, it's beautiful and it smells nice. Here we have its functional group F as carbon bonded to 2 oxygens, meaning 2 carbons bonded to 2 oxygens. One carbon is bonded to an oxygen by a double bond, and another carbon is bonded to oxygen by a single bond. In this case, I think I'll just show you when we do esterification, things will be clear on what is it that I'm saying right now. So the simple way of showing you this thing is this. It has what we call the functional group that has COO. So this COO, it is in between. So meaning, as you can see, it is enclosed. This thing. It is in between some things. Maybe we can also proceed to add carbons here. As many carbons as we want. So the C that is bonded to oxygen, it is in between the whole structure. I think I should also do carboxylic acid. I'll finish with alcohol. So because why am I choosing to do carboxylic acid? They have the same on phase value, same functional group, because this C double bond O here, it is in between, but there it is on the outside. I'm going to show you. Here we are. We can only add carbons on the side. But on that side, it is closed by that hydrogen. But here, we can add carbons indefinitely. But there, we can only add carbons on one side. This should remind us of something. Here, the functional group has COOH. But here, the functional group is COO. I think you should, I don't know if maybe you get what I'm saying. There is COO closed by the H. Here is COO not closed by the H. So there is a link. There's something that I want to show you. I've just done ketone and aldehyde previously. Now I'm doing ester and carboxylic acid. Here we have the functional group being on the first carbon. Functional group being on the first carbon. But here, the functional group is in between two carbons. Functional group is in between two carbons. So it's clear that these two have a similar characteristic with the first two, the previous two that I've done, which is what? Aldehyde and ketone. This one, since it is in between two carbons, resonate with ketone. That one, which is carboxylic acid, since it is on the first carbon, resonates with aldehyde. You know, as we go further on this particular journey of identifying or rather organic chemistry, you will see these four homologous series, they are called functional isomers. So meaning aldehyde, its functional isomer is ketone, carboxylic acid, its functional isomer is ester. You see, because they have the same, or rather, they share the functional isomer, meaning if I move the position of the functional group, it will give me something else that I would be wanting to get. Carboxylic acid, ester. Let's proceed to the last one. They normally say save best for the last. As I normally know, our country has a lot of it has a drinking culture, so many people, when they hear the word alcohol, their brain kicks something. But this simply means alcohol is a family, because we have different types of alcohol inside. So whatever that people drink, just to help them to remember something, you are drinking an alcoholic beverage, meaning it is a beverage that has certain percentage of alcohol in it. You are not basically drinking alcohol. Anyway, alcohol has its functional group. It can be placed anywhere. It has its functional group as an OH. It can be placed anywhere on the structure, on the diagram. Can be placed anywhere on the structure. Just to make things clear, the structure will be having a single bond between carbon atoms. So functional group, it is OH. So we can put it anywhere. Let me show you the structure. 1, 2, 3. You can put the functional group anywhere. However, there is something that by placing this functional group here, it means something. When I place it maybe on the first carbon, it means something. When I place it on the carbon that has other things on it, it will mean something. Maybe the carbon bonded to the functional group is bonded to 3 other carbons, then that will be something else. So things will be clear as we go further, proceed with this particular topic. So I have basically, what is it that I've done in this session? I've introduced to you the organic chemistry topic, told you about the valence electrons of carbon having 4, and then carbon having to bond with a maximum of 4 electrons, or rather, elements. And then there will be different elements that carbon is going to be bonded with. I've listed them as your hydrogen, and then as your oxygen, and as your halogens. And under halogens, I've mentioned 4. I said fluorine, iodine, and bromine. And then from there, I've shown you all the different nine different types of homologous series, which is alkane. What is it that I've said alkane was? Alkane is a type of homologous series that has single bonds between carbon atoms, and it is only surrounded by hydrogens only. Alkene, it has double bonds between carbon atoms, maybe minimum of one double bond between carbon atoms, and then it is also surrounded by hydrogens only. The third one, alkyne, it has triple bonds between carbon atoms. Similarly to the first two, it is only surrounded by hydrogens only. There is a name for that package of the first three homologous series that we will learn about as we go further. Spoiler alert, it is called hydrocarbons, meaning molecules that consist of hydrogen and carbon only. Cool. The third one, we said it is a haloalkane. Haloalkane, I said, it comprises of two words, a halogen and an alkane, meaning we're going back to alkane, but we are going to fiddle with the structure a bit and add halogens here and there, hence it is going to be called haloalkane. Remember, alkane has single bonds between carbon atoms. Even this particular structure, which is a haloalkane, it has single bonds between carbon atoms. However, now it is surrounded by two things, halogens and hydrogens only those two, halogens and hydrogens. The fifth and the sixth, I combined them into to show you the difference between the two. And first one is this aldehyde. Aldehyde has single bonds between carbon atoms. Maybe I forgot to mention that. Single bonds between carbon atoms. And the functional group, which is a carbon bonded to an oxygen with a double bond, it is on the first carbon. First carbon. And then we have a ketone. Ketone, it has single bonds between carbon atoms. And then the carbon bonded with a double bond to oxygen is in between two other carbons. And please remember, other than oxygen, there's only hydrogens, but we will get to that. There can be something else also. But I just want to emphasize this. The double bond between carbon and oxygen, that carbon that is bonded to oxygen with a double bond for ketone is in between. But for aldehyde is on the first carbon. Ester. Ester has a COO functional group, meaning carbon is bonded with a double bond to oxygen and another oxygen. So it is in between two other carbons. You see, ester has its brother or sister with a carboxylic acid because they share the C double bond O functional group. And then the C double bond COO functional group for ester is in between carbons, and then for carboxylic acid is outside, meaning it's in the first carbon. That is the difference between ester and carboxylic acid. The last one, which is this one that is on the board, alcohol. Alcohol has an OH functional group. In the next session, I'm going to give you everything with the names of all these different functional groups, on which what does this functional group mean. If they ask you what is the name of the functional group of a certain homologous series, you just have to give us the name of that particular functional group. So for alcohol, it has its OH bonded to any carbon on the carbon chain. So it can be on the first, the second, the third, the fourth, the fifth, until we get to the last one. So basically, that's what I wanted us to deal with, or rather to look at today, which is the 9 different types of homologous series and their functional groups, and then how do we see them. And I hope this lesson was fruitful to you and for you. I also ask you to comment there in the comment section and then ask questions and tell me what is it that you would want me to fix or rather to do. And then from there onward, see you in our next lesson. Thank you. Bye-bye.